Is this thing on? Hello? Oh yeah, it is. Okay, hi, I'm Ethan Kwan, and today we're going to be learning about 30, 60, 90 triangles and 45, 45, 90 triangles. What are they? And what's the point? Okay, so let's answer the first question. What are these triangles? The 30, 60, 90 triangles and 45, 45, 90 triangles. Well, these, if you're wondering. Remember, they're triangles, so I'll explain why they're called 45, 45, 90 triangles and 30, 60, 90 triangles in a second, but let's just look at them for now. Ooh, nice triangles. Okay, so, let's start with the 45, 45, 90 triangle. It is a little bit easier. So here is our 45, 45, 90 triangle. Wee, Bob. Bob, Bob, Bob. Okay, let's start. Okay, so why is it called a 45, 45, 90 triangle? Well, basically because the angles in the triangle are 45 degrees, and 90 degrees. So, like this. Okay? So, this is a right triangle, obviously. So, clearly the Pythagorean theorem should apply. Okay, so here is our triangle, right? Now, what we're going to do is we're just going to flip it, right? So that the long side, the hypotenuse, is lying on the bottom. Okay, now notice the two angles on the bottom. They're both 45 degrees, right? Okay, so that means that this is an isosceles triangle, right? So, an isosceles triangle always has two sides that are equal. In this case, these two. Okay, so let's flip it back right way up again. Okay, so that means that if one of the bases is x, the other base is also x. Okay, so now we're going to use the Pythagorean theorem to find out what this hypotenuse length would be. Okay, so let's just go on a little aside. Okay, so we know from the Pythagorean theorem that x squared plus x squared equals c squared, which means that 2x squared equals c squared, right? We just combined the x squareds. Okay, and that means that now just divide both sides by 2, and you get x squared equals c squared divided by 2. Now we can take the square root of both sides. The square root of x squared is just x, and the square root of c squared over 2 is going to be, well, because of square root properties, you just have to take the square root of the top and the square root of the bottom. So, so the square root of the top would be just c, and the square root of the bottom would be square root of 2, right? Okay, so now we have our answer. So x is going to be equal to c divided by the square root of 2. Now, weirdly, nobody really likes the radical in the denominator. It's really weird, but I don't know why. It's just people think that way. So we want to get rid of this. In the bottom, anyway. Okay, so what we're going to do is we're going to move this over. Okay, so, and we have our x, and here is our result, right? Now we're going to multiply it by something, and this something is going to be square root of 2 over square root of 2, because anything over anything else equals 1, right? So we're basically multiplying it by 1, okay? So if we do that, we just multiply the top and the bottom. The top becomes c times square root of 2, c square root of 2, and bottom becomes square root of 2 times square root of 2, which is 2, right? Okay, so we get this. Okay, so now what we have is this equation. So now we know for a 45, 45, 90 triangle, one of the sides, the x side, will always be square root of 2 over 2c, right? So if we go back and speed forward through this, you can see that if we just move the c part down to like on the side, we just get this. Okay, so here is a real problem that you might want to solve. Okay, so here is our problem. So you're given 8 for one of the sides, and you want to figure out the hypotenuse given one of the sides. Okay, So we use this equation, and we're gonna go off on a little aside. This is like all my equations are in here, okay? In these boxes. Okay, so we know that 8 equals the square root of 2 over 2c, right? Because x is gonna be 8, so 8 equals square root of 2 over 2c. Okay, now we multiply both sides by the inverse of square root of 2 over 2, okay? And that would be, you just flip the, yeah, like that. So it's, the inverse of square root of 2 over 2 is going to be 2 over the square root of 2. Okay, so now we have this result. Okay, and we multiply both sides, of course. Now, 2 times 8 is 16, so we're going to get 16 over the square root of 2. And, of course, the two square root of 2 over 2's on the other side, on the x side, cancel out, so we get this. So our answer is x is equal to 16 over the square root of 2. Now, of course, like I said, nobody likes the radical in the denominator. Ooh, say that fast 3 times. Okay, so so if we calculate this again, all we do is multiply by square root of 2 over square root of 2. So we get 16 square root of 2 over 2. Now, there's a way to simplify this, right? So we get 16 square root of 2 over 2. So there's a way to simplify this. So 16 divided by 2 is going to be 8. So the actual answer would be 8 square root of 2. Okay, so good job. You've just done your first ever 45, 45, 90 triangle problem. Okay, so let's go to the 30, 60, 90 triangle. It's a little bit harder, but I'm pretty sure you'll understand what it is. Hey, no, that's not supposed to happen. Oops. You know what? Okay, never mind, that didn't work. Okay, anyway, so here is our 30, 60, 90 triangle. As before, the reason it's called a 30, 60, 90 triangle is because the angles are 30 degrees, 60 degrees, and 90 degrees. Now, let's call the hypotenuse h. Okay, now, we're to find out the rest of the sides, we're going to do something a little bit sneaky. We're going to flip the whole triangle over, like this, right? So they're exactly the same angles, even the numbers are flipped. Okay, so we know that the two bottom angles are 60. The top angle is 30 degrees plus 30 degrees, which is going to be, well, 60 degrees. Now we know that we're dealing with what's it called? Equilateral triangle, right? Because if all 3 angles are 60 degrees, then, well, it's going to always be an equilateral triangle. And if it's an equilateral triangle, all 3 sides are going to have the same measure, okay? So, h. Now, that means that for our original triangle, this length here, this length is going to be h over 2, or h divided by 2, because it's halfway across, right? Okay, so, let me just get rid of this last little part, the other side, yeah. Yeah. Yep. Okay, there we go. Okay, so now if we go back to our original triangle, that means that bottom length is h divided by 2. Interesting, because the base, or the bottom, is always the hypotenuse divided by 2. That's really interesting, because normally you'd get like a square root answer or something. Okay, so what we're going to try and do is find out this side, the x side. Okay, so let's go off on our little aside here. Yeah, okay, there we go. Okay, so, yeah, I added that little space there because, well, we're going to need more space. Okay, so, we know that, now we can use the Pythagorean theorem to find out that h divided by 2 squared plus x squared equals h squared, right? Now, let's square the h squared, h over 2, so we get, because of properties, power properties, right? That's what they're called. Okay, so power properties tells us that you can just square the top and square the bottom, just like the square root. Okay, so h squared is just h squared, and 2 squared is 4, right? 2 times 2. Okay, so, so our equation is that now. Now we can subtract h squared over 4 on both sides, and you get x squared equals h squared minus h squared over 4. Now we're going to factor out a h squared, and those of you who don't know how to do that, just take my word for it. You can look it up after. What we do is we just pull the h squared out and just replace it with the coefficient. So, like this. So we just pull it out like that. So, for example, the first term was h squared. Now it's just 1 because that was the coefficient. So we just take it out. Because of the distributive property, this is just equal to the top, right? Or the 1 on top. Okay. So, we can simplify this. What is 1 minus 1/4? Well, it's going to be 3/4, right? And then we can swap the order because it's multiplication, and we get 3/4 h squared. Now, we're going to take the square root of both sides. The square root of x squared is just x, and the square root of 3/4 h squared, because of the property, we're going to get this answer. So, x is equal to square root of 3 over 2h, right? Okay, so, because, well, the square root of h squared is just h, and square root of 3 is square root of 3, it's just a long decimal expansion, and the next one is going to be square root of 4, which is 2. Okay, so, now we figured out that if you know the hypotenuse, then you can figure out all the other sides. Now, this is kind of confusing, and there are a lot of divided by 2's, so I think it would be easier if we multiply everything by 2, right? Because if you expand something but keep its dimensions, it won't change the value. So 2 times h over 2 is just going to be h, right? And square root of 3 over 2 times 2 is going to be square root of 3, and 2 times h is just 2h. Right? So now the dimensions are given by this little bottom segment, h. We can just call that x if you want. Okay, so let's do a problem. Okay, so we have this problem where we have a 30, 60, 90 triangle. We can figure that out because there's a 90 degree and there's a 30 degree. Now all angles in a triangle have to add up to 180 degrees, so what we're going to have 180 minus 30 minus 90, right, which is going to be 60. Okay, so we know this is a 30, 60, 90 triangle. Now, I think instead of solving for x right away, I think it's easier to solve for the base first because that's just half, right? Remember? So we're just going to solve for y first. So we know that 8 equals 2y, right? Because y times 2 is always the hypotenuse, right? Okay, so we're going to divide both sides by 2, like that. And 4 equals y. So y is 4 units. Okay, so what is x now? Well, x is going to be y times the square root of 3, which is going to be 4 times the square root of 3. So it's pretty easy to figure out now. X is, of course, going to be 6.92820323028, and so on. Okay. I don't know. I don't know why I did that. Okay. So let's do some more example problems. Let's do some example problems. Oh no. No, come back. Problems. No. I don't know what happened there. Yeah, anyway. Okay. Oh, do almost touched problems, but okay. Okay, whatever. So, next slide. So, ABCD is a parallelogram where CE is 15. CE, the segment CE, is 15. BC, the segment BC, is 6. And the angle ADE is 90 degrees, and the angle BAE is 120 degrees. What is the area of ABCD? Now, this might seem like there's no relation to 30, 60, 90 triangles or 45, 45, 90 triangles, But bear with me here, and I'm going to just show you a little animation of how 30, 60, 90 triangle can be found here. Now, remember that how I said that ADE is a right angle? So that's going to be really useful. So that's the first thing I specify here. Okay, now that's 30 degrees because 90 minus 120 is 30. So we're just going to draw a 30, 60, 90 triangle, right? So this is just ADE. So AED. So ADE, yes. So triangle ADE. So we know that's 60 because that other angle is 30, and there's a 90-degree angle. So we know that unit is 6. So that's the bottom is 3. So yes. Okay. Okay. That's the area of a parallelogram. Okay, so the area is 45 square roots of 3. Now, you can play that again and slow it down if you need to, but I'm just going to move on to the next problem. Okay, so let's do another one. Oh no, wait, what happened there? It's really bouncy for some reason. I don't know why. Wow, dew is really sliding off, isn't it? Dew, come back. Okay, it stopped. Okay, anyway. So, kite, K-I-T-E, is a kite, where K-E, the segment K-E, is 8 square roots of 2, and E-T is 17. Okay, so what is the area of kite, K-I-T-E? Okay, so, I'm just going to do another animation. So, here we go. So, we're going to draw the diagonals, right? Now, that's a right angle. Okay, so we know that's x. So given that it's a 45, 45, 90 triangle, that those two units are also x, we can figure out that x is 8, right? Because of 45, 45, 90 triangles. That means we know EI, the segment EI is 16, right? So KT is 8 plus y, right? Because the bottom, like, up and down diagonal. So this will show you how we calculate the segment KY. KT, I mean. Yep, there we go. Y is 15. So the area of a kite is always 0.5 times D1 times D2, diagonal 1 times diagonal 2. So the answer is 184. Okay, thank you for watching. I hope you liked this video. If you did, please subscribe, like, and share this channel with others. And well, if you didn't, well, do whatever you want. Thank you for watching, and I'll see you next time. Oh, and by the way, don't forget to go to howtodosofeverything.com to see more videos and amazing stuff. See ya. Bye.